few things for week 3. First off, if I have 5 shirts and 3 pairs of pants, how many combinations can I make? So if I have 5 shirts, we'll call this shirt 1, shirt 2, shirt 3, shirt 4, and shirt 5. Each of those could go with each of my pairs of pants, right? So I could have shirt 1 paired with pants 1, shirt 1 paired with pants 2, or shirt 1 paired with pants 3. And I can do the same thing for each one of these. So the big concept is, for every first option, I have all my second options, right? My second thing that I can choose from, right? So for each of these, I have 3 options. So for the first one, I have 3. For the second one, I have 3. Third one, I have 3. Fourth one, I have 3. Fifth one, I have 3. So for all 5, I'm going to have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 outfits. So you'll notice that the way I come up with that is I do 5 times 3 is 15. Don't memorize that, oh, I'm supposed to multiply or whatever, right? Think about why we're multiplying, right? We have 3 or 5 groups of 3, right? That's what's going on here, right? I have a group of 3 here, 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 a group of 3 here. So I have 5 groups of 3. If this problem was more complicated, like I also had 4 shoes, 4 pairs of shoes that I could do, and I'll do that in a different color, then I would have, with each of these ones, right? The shirt 1, pants 1, I'd have 4 possible shoes that I could go with. And I'll call them shoe 1, shoe 2, shoe 3, and shoe 4. And you can tell they're different than my other S's because they're turquoise. So now I would have 1, 2, 3 times 4. So I'd have 3 groups of 4, right? Because I'd have 4 options here and 4 options there. So there's 3 groups of 4. But there's 5 3 groups of 4 in actuality, right? Because I have all of these as well. So I would have 3 groups of 4, right? A group of 4, a group of 4, a group of 4, for every 5 that I had before. So now my answer is going to be 5 times 3, the original amount, and then each of those is going to have 4 different options. So altogether I'll have this, which is going to get me 60 different outfits. So this concept is really important to understand. Don't just memorize that, oh, I'm supposed to multiply. Because there are times when you won't multiply. You'll add for other problems, or you subtract for other problems, or you have to do a bunch of other stuff, right? So just memorizing that, oh, I'm supposed to multiply, isn't really helpful, right? But understanding why and when you can use this is. So for instance, if we're talking about something like this, if I have 6 students and I need them to sit down in a row, well, we have 6 chairs for them to sit in then, right? So in the first chair, I would have 6 options that can go there. So you can think about it as chair 1 has 1, 2, 3, 4, 5, 6 options, right, for 6 students. And so would chair 2, so would chair 3, so would chair 4. Except once a student sits down, I no longer have 6 options, right? Once I picked one of these students, 1, 2, 3, 4, 5 people could sit in chair 2, right? And in chair 3, only 4 people could sit there because 2 of them have already sat down out of the 6, right? So as it goes along, I'll have less and less choices, right? So for the first chair, I'll have 6 options. And then once I choose one of those, let's say I choose person A to sit in chair 1, then I will have a certain number of options left over to sit in all the other chairs. So if I choose A, the next one I could choose is B. I could choose C, I could choose D, I could choose E, I could choose F, right? And from then on, I could choose any number of combinations. But I also could go back after I've done every combination with A being first. A, start with B, then do a bunch. A, start with C, then do a bunch. A, start with D, and then do a bunch, right? After I've done all of those, then I could go back and I could choose not A, but this time I could choose B to be the first one. And with B being the first one, I wouldn't have B as an option here, but I would have A, right? I'd still have 6 options. So B would get all these options, or I should say 5 options, right? B would have all these options, right? So all of those would go with B being first. And then I'd have C being first and all those options, right? So the way we're going to calculate this is that for each of these 6 starting letters, I could start with A, I could start with B, I could start with C, right? Any of those. For each of those 6, they'll have 5 options here, And those 5 options, once I've chose one of those 5, I'll have 4 options to choose from. And then once I choose one of those 4, I'll have 3 options to choose from, and then 2, and then finally the last person will sit down. So in other words, 6 factorial is how many choices we'll have here, right? Because every time we make a choice, we have 1 less than we did before. So originally I have 6 choices. Each of those choices that I could make will have 5 choices to go with them, right? And on and on and on until I get 6 factorial. Now, if I have a problem like this, which is notated like this, it means 4 choose 3. What it means is, unlike this, which is 6 choose 6, right? I have 6 kids and I'm going to choose 6 of them, right? Until I'm out of children to sit down, right? This says I have 4 things and I'll choose 3 at a time. So what that might be like is this, where I've got 4 different pens, and I'll make it as different as I can. 4 different pens, let's choose a blue. And I want to choose 3 of them to make my set. So I could choose the first 3. I could choose these 3 starting with the blue. I could choose these 3 excluding the blue, right? There's lots of different options. So 4 choose 3. Another way of thinking about it is similar to the student's problem. For my first choice, I have 4 options, right? So there are 4 options. I could start with red, right? And the next option I could choose would be 3. So once I've chosen red, I have 3 options to choose, right? So every time I choose the first one, I have 3 left over. So each of these 4 options, if I chose purple first, right, I'd have 3 left over. If I chose green first, I'd have 3 left over, right? I have 4 options, then I have 3 options because I've chosen 1. And then once I've chosen 2, I have 2 options left. And then since I've chosen the 3 that I want, remember, we're just choosing 3 of the 4. I'm not choosing all of them like I did for the kids, right? Not everybody has to sit down here. I only need to pick 3 of them. Then I'm done. I don't go on any further, right? 4 choose 3 means I have 4 options and I'll choose 3 of them. So how many options do I have for the first choice? Well, I have 4 options for my first choice. Once I make it, I have 3 options. Once I make it, I have 2 options. And then once I make that, I'm done. I don't care what's left. So my total number of choices is going to be 12 times 2, which is 24. If I did 5 choose 3, then I would have this going on, right? I could have like a pink pen in here. 5 options would be my first choice. 4 options for my second choice. And 3 options for my third choice. And once I've made my third choice, I no longer have to go any further. I've chosen 3 pens. It's time to stop. So my answer would be 20 times 3, or 60 possible ways I could have 5 objects and choose 3 of them. Last thing I want to talk about is counting, to really review all that we've done in chapter 1. So if I'm counting numbers, like let's say 1, 2, 3, 4, all up to 20. How many numbers are in this list? Well, because it goes up by 1, right, and it goes from 1 to 20, it's very easy to say that there are 20 numbers here. No shock, right? So this is the ideal problem, right? We want every problem to look like that. So when we get a problem like this, 8, 9, 10, 11, all the way up to 29, we can turn this problem into one of these problems, a problem that starts at 1 and goes up by 1. And the way I can do that, since it already goes up by 1, right, 8, 9, 10, 11, is I can just subtract everything down. And if I subtract both 8 and 29, right, and I move them the same amount, let me do it this way. If I move them the same amount, then the number of numbers won't change. And let me show you what I mean. So if I subtract 7 from all of these, that'll turn this into a 1, 2, a 3, 4. And if I subtract 7 from my last number, I'll get 22. So clearly, since every number has been subtracted, right, I haven't removed any numbers, right? They're all there. I just made them smaller, right? Each number is here, right, all the way up. It's clear that there are 22 numbers in this set. That means there must have been 22 numbers here, because I didn't change how many numbers are here, right? This 1 goes with the 8, the 2 goes with the 9, the 3 goes with the 10. There's a number in this list for every number in this one, right? And so we know that if this list has 22, then this list will also have 22. Making it a little more difficult, starting on 8, but not going up by 1. 8, 11, 14, 17, 35. So if we continue our pattern, we see that we're going up by 3, right? Ideally, what we want to do is we want to have this list look like this, right? Because this list is easy. And what's easy about it? It starts at 1 and it goes up by 1. So first off, this doesn't go up by 1. So the first thing we want to change is to make it go up by 1. Let me say it again. Do I want to do that? Oh, let me think. I want to make it go up by 1. Let's do this. Because it's going up by 3s, instead, let's make it so everything's divisible by 3. So right now, 8 is not divisible by 3. 11 is not divisible by 3, right? So if we subtract to make them divisible by 3, things will be easier. Or you could add, I suppose. Let's add. So if I add 1 to everything, it's going to make all the numbers 1 bigger, but it's not going to change how many numbers are in the list, right? There's still a number for every number. So 35 becomes 36, and there's still the same number of numbers in this list. But now what's nice, because they're going up by 3 and they're divisible by 3, now I can divide everything by 3. And again, dividing everything won't change the number of numbers in the list. It'll just change what they look like. So if I divide by 3, I get 3. If I divide by 3, I get 4. If I divide by 3, I get 5. If I divide by 3, I get 6. And if I divide this by 3, I will get 12. So while it's not obvious how many numbers are in this list yet, it's much easier to tell how many numbers are in this list than this one. 3, 4, 5, 6, all the way up to 12. Now, to make it really easy to count, we could subtract 2 from everything, right? Because now it'll start with 1, then it'll go to 2, then it'll go to 3, then it'll go to 4, and then it will go to 10. So it looks like there are 10 numbers in this list, which means there are 10 numbers in this list. Cool. So this is the strategy you want to employ every single time. What is it going up by? Cool. Let's make it divisible by that number. And then after it is, divide it, and then make it go up by 1s. That's our strategy.